Dear students, in today's class we will discuss about project evaluation and review technique. Okay, in last class we discussed about the critical path method or CPM in network analysis, right? So in network analysis the second technique is project evaluation and review technique. Now what is the major difference between critical path method and PERT is that in case of critical path method or CPM, all activity timings are deterministic in nature. Okay, basically CPM is activity oriented technique while PERT is event oriented technique. Okay, and in CPM, as we had already discussed in the last problem, all the timing or the duration given is deterministic in nature. But in case of PERT, there are three different time estimates, that is optimistic time, most likely time and pessimistic time. So whenever a problem comes and in that problem if three different time estimates are given, then you need to understand that you have to use PERT or project evaluation and review technique. Okay, now we will discuss PERT in detail using a problem. So before going into the problem, there are two different formulas that you need to remember while solving a problem using PERT. First one is expected time or TE, and it is given by T is equal to TO plus 4TM plus TP divided by 6. Here TE refers to the expected time, TO refers to optimistic time, TM refers to most likely time and TP refers to pessimistic time. Okay, so expected time is equal to optimistic time plus 4 times most likely time plus pessimistic time, the whole divided by 6. Okay, and then you have another formula for variance, and variance is given by sigma squared is equal to pessimistic time minus optimistic time divided by 6, the whole squared. Okay, these are the two formulas which you need to remember while solving a problem using PERT. Okay, now we will discuss PERT using a typical problem. Now look at the question. Consider the following table summarizing the details of a project. So the different activities are given, predecessors are given, then duration is given in week, but you have three different time estimates. One is optimistic time, most likely time and pessimistic time corresponding to each and every activity. Now in the question it is asked, you need to construct the project network, then find the expected duration and variance of each activity, find the critical path and project completion time, and it is the last sub question is what is the probability of completing the project on or before 22 weeks. So this is a question. Now here the first thing that we need to do is we need to draw a network diagram. Only if we draw a network diagram we will be able to proceed with the question. Whether it is for PERT or for CPM, the first step is to draw a network diagram using the given data. So first let's draw a network diagram using this particular data. Okay. So what is given in the question? You have you have activities from A to J. Their duration is also given. Then the predecessors is also given. Okay. So let's see. Now if you look at the question, you can see that you have three different activities A, B and C where there is no predecessors in this particular activities, right? So what does that mean? It means that all these activities are starting from the starting node. Okay, there is no predecessors for these three activities. So what you need to do is we will draw the first node, that is node 1. So you have the first node and you have three activities coming from this node, A, B and C. Okay, so these three activities, they don't have predecessors. So let's see, this is the second node, 2, 3 and you have the final one, 4. Correct? So these three activities does not have any predecessors. Now look at the next activity, activity D. Activity D has predecessor A. That means activity D will take place only after A is complete. So where is activity A getting completed? At node 2. Now before drawing D, we need to check whether D is the predecessor of any other activity. So if you check, you can see that D is the predecessor of I and D is an independent activity, right? There is no particular activity along with D. So soon after A you can draw D, and where D is ending, there I will start. Okay, So from 2 you can draw activity D. Okay, so this is ending in the next node, that is node number 5. Now look at the next one, E. So activity A, B, C, D is done. The next is E. E, the predecessor is B, and check whether E is the predecessor of any other activity. So E and F are predecessors of H. So now we can see that E and F are ending at the same node, and E will take place only after B is complete. So what you can do is, B is getting completed at node number 3. So from here you can draw activity E. Okay, activity E which ends in another node, and here you have to be careful about one thing. Here E and F are ending at the same node. That means there will be one more activity which will end at node 6, that is F. Okay, now look at F. F happens only after C is complete. So predecessor is C. So F happens after C. So where is C ending? C is ending at 4. And we know that E and F are coming together. See, E and F are ending at the same node. So from 4 you can draw an arrow towards 6, and this is F, activity F. Then look at the next activity, G. G has C as the predecessor. So G will happen only after C is complete. Now G is the predecessor of any other activity. G and H are predecessors of J. So H and G will end at the same node. Okay. So from C, where is activity C ending? 4. From here you can draw G, correct? So you will draw another arrow G which ends at another node number 7. Okay. Now look at H. H will happen after E and F gets over. That is, E and F are the predecessor of H. E and F is ending at 6. So from here you can draw H towards node number 7. Because why? Because G and H are ending at the same node. Correct? G and H are ending at the same node. Now look at the next one, I. I happens after D. Okay, so I is here. I happens after D. So you can draw another one arrow I, and this is ending at another node 8. Now see, I is the ending activity. It is not the predecessor of any other activity. Now look at J. J happens after H and G is complete, and again J is not the predecessor of any other activity. That means I and J here, they are the ending activities. Okay, so after H and G gets over, at 7. So from here you can draw an arrow towards node number 8, right? This is J. Okay, so this is our total network diagram. So you have 8 nodes, that means 8 events and activities from A till G. So I hope this is clear. So the first part of the question, that is construct the project network, that part is complete. Okay. Now the next part of the question is find the expected duration and variance of each activity. Now first part is complete. We have our network diagram. This is our network diagram. Now you need to find the expected duration and variance of each activity. Now in PERT, what is the formula? Expected duration or expected time is given by this formula, and you have variance given by this formula. Using these two formulas we need to calculate the expected time and variance. Okay, so first let's find out the expected time. Expected time for each and every activity. Okay, now consider activity number A. Activity A. Okay, so what is the expected time? What is the formula? According to the formula, it is given as TO, that is optimistic time plus 4 times the most likely time plus pessimistic time divided by 6. Okay, now look at the question. So activity A, what is the optimistic time? Optimistic time is 5. So according to the formula, it is optimistic time plus 4 times most likely time. So it is 4 into 6 plus pessimistic time, that is 7, divided by 6. Yes or no? This is the formula. TO plus 4 times TM plus TP divided by 6. So TO plus 4 into TM plus pessimistic time, the whole divided by 6. So you get 4 expected time for activity A. So 5 plus 4 into 6 plus 7 divided by 6, you will get the answer as 6. Now for B, again the second activity. So look at B, 1 plus 4 into 3 plus 5 divided by 6. So you will get the answer as 3. Okay. Now for C, you will get it as, for C, 1 plus 4 into 4 plus 7 divided by 6. So you will get the answer as 4. So for similarly for all these activities, you need to find the expected time. Okay, so let's find out the expected time for each and every activity and write it down in a table. So the table will look like this. Okay, you have activities, duration, mean duration and variance. So for each and every activity, you need to write down the calculated expected time. So here we have found out for A it is 6. So for A it is 6. Then for B it is 3. Then for C it is 4. D it is 2. Then E it is 3. Then for F 5. Then G 3. H 5. Then I it is 5 and J it is 3. So using the formula you calculate the mean duration and we write it in the table. Similarly you need to calculate the variance as well. So how you will calculate the variance? Again for variance, so for calculating the variance you have another formula, right? So what is the formula for calculating variance? TP minus TO divided by 6 the whole square, right? So sigma squared is equal to TP minus TO, that is pessimistic time minus optimistic time divided by 6 the whole squared. So for each and every activity you need to find the variance. Now consider for example for A, how you will calculate. So for A, TP is 7. So 7 minus TO, that is 5. Okay, divided by 6. 7 minus 5 is 2. 2 divided by 6 the whole squared. So you will get this as 0.11. Then for B again 5 minus 1 divided by 6 the whole square. 5 minus 1 divided by 6 the whole squared. You will get 0.44. You can use calculator for finding this. Okay. So similarly for all the activities. So for C you will have 7 minus 1 by 6 the whole squared. Then 3 minus 1 by 6 the whole squared, 9 minus 1 by 6 the whole squared, 9 minus 1 by 6 the whole squared, 8 minus 2 divided by 6 the whole squared, 10 minus 4 divided by 6 the whole squared, 8 minus 2 divided by 6 the whole squared, 8 minus 2 divided by 6 the whole squared. So for each and every activity you need to find the variance and then write down in this particular table. So for A the variance is 0.11. For B it is 0.44, for C it is 1, then for D it is 0.11, then E 1.78, then for F it is 1.78, then G it is 1, H 1, I 1 and finally J also you will have variance as 1. So now you know the mean duration as well as the variance using the formula, right? So the second part of the question, that is calculation of expected duration and variance of the activities. So this much is clear. Okay, now we will move on to the next part of the question. The next part of the question is to find the critical path and project completion time. So in the last video we discussed how to find the critical path and project completion time in detail. First you need to calculate the you need to draw the network diagram, which we have already done. Then using that you need to calculate the earliest start time and latest completion time. So here in this particular problem our duration is given in 3 different time estimates, right? So here the mean duration for each and every activity is considered as the deterministic time. So now you know the mean duration, we have already found out the mean duration. So for each and every activity this duration is considered for finding the critical path. Okay, then the rest of the procedure is same just like how we did for CPM method, correct? Okay, so you have your project network diagram, or the network diagram is given. So here you can write the duration for each and every activity. So how you will write the duration? See, for A the duration is 6, correct? So you can write down there. So 6. Then for B the duration is 3. Then for C the duration is 4, right? So A6, B3, C it is 4, D2, E3, F5. So for D it is 2, for E it is 3, F5, G3, H5, I5, and J you have the duration as 3. So you are considering the mean duration as a duration for each and every activity in order to find the critical path. Okay, now to find critical path, it is the same method, that is you have to determine the earliest start time, that is a forward pass, and the latest completion time, or the backward pass. Okay, so for earliest start time you have this formula, ESJ is equal to maximum of ESI plus duration. So in case of any first activity in any network diagram, the earliest start time of the first activity is 0, right? So here in the network diagram we can do these two things. So here we will be writing the ES and LC is here, right? The earliest start time for the first activity it is 0, fine. Then for the second activity, for the second node, you can see the earliest start time is equal to maximum of ESI plus duration. So what is it? For the preceding activity is A, so 0 plus 6. So you have 0 plus 6, you will have 6 as the answer. Then for the third one, it is 0 plus 3, so it is 3. Then earliest start time for the fourth node, so it is 0 plus 4, 0 plus 4 it is 4. Then fifth node, so what is ES2? ES2 is 6, so you have 6 plus duration of D, that is 2, so this is equal to 8. Then ES6, so here ES6, two things are coming, two activities are coming towards node 6, so that means this is maximum of, so maximum of 3 plus 3. Why? 3 for the third node it is 3 plus 3, comma, then fourth node it is 4, right? ES4 is 4 plus 5, 4 plus 5, so this is 6 and this is 9, right? So you will get 9. Then ES7, so ES7 it is maximum of 9 plus 5, comma, 4 plus 3. Why 19? Then here again for 8 it is maximum of 8 plus 5, comma, 14 plus 3. So you will get 17. Why? This is 8 plus 5 and 14 plus 3. So it is 17. So now you have all the ES values for all the nodes, right? Now next you need to find out the latest completion time. How will you calculate? LCI is equal to minimum of LCJ minus duration. Okay, so for any network diagram, the LC value you are doing the backward pass. So for LC8 will be same as ES8. So LC8 is equal to 17. Now here LC7, look at, okay, now look at LC7. So LC7 is equal to LC8 minus duration. So LC8 is 17 and duration for that is 3, right? Minus 3. So it is 17 minus 3, you will get the answer as 14. Okay, then LC6 is equal to 14 minus 5. LC6 is equal to, from here there is only one now, so 14 minus 5. So this is also 14, this is 17. So 14 minus 5, you get 9. Okay, so the answer is 9. Then LC5 is equal to 17 minus 5, 12. Then LC4 is minimum of 14 minus 3, comma, 9 minus 5. So this is 4. Then LC3 is 9 minus 3, which is equal to 6. LC2 is 12 minus 2, which is equal to 10, and LC1 is again minimum of 10 minus 6, comma 6 minus 3, comma 4 minus 4. So finally you will get 0. Okay, so you need to write the LC values for each and everything. So for 8 it is 17, 7, 40, 6, 9. Then for 5, LC5 is 12. Then LC4 is 4. LC3 is 6. LC2 is 10. And LC1 is 0. So now you know the LC values and ES values for each and every node. Now you need to find the critical path. How do we find the critical path? Critical path, the condition for critical path is ESI is equal to LCI, ESJ is equal to LCJ, and ESJ minus ESI is equal to LCJ minus LCI is equal to duration. Correct? So here you can look at this. So when you look at this, ESI is equal to LCI. So here which all values are equal? So for 1 it is equal, then for 4 it is equal, 6 it is equal, 7 equal, and 8 equal. Now 17 minus 14. 17 minus 14 will give you 3. Then 14 minus 9 will give you 5. Okay. 9 minus 4 will give you 5 again. Then 4 minus 0 will give you 4. So that means all the conditions are met. All the conditions for critical path, that is ESI is equal to LCI, ESJ is equal to LCJ, ESI minus ESI is equal to LCJ minus LCI, which is equal to duration. So all these conditions are satisfied by these activities. So it is 1 to 4, then 4 to 6, then 6 to 7, and finally 7 to 8. So this is our critical path: 1 to 4, 4 to 6, 6 to 7, and 7 to 8. So you can write down critical path is 1 to 4, 4 to 6, 6 to 7, and 7 to 8. Okay, 1 to 4, 4 to 6, 6 to 7, 7 to 8. Now what are the critical activities? So critical activity is given by 1 to 4. So what is 1 to 4? 1 to 4 is C, correct? C. Then 4 to 6 it is F. Then 6 to 7 it is H. And 7 to 8 it is J. So these are our critical activities. Okay, you need to find the project completion time. So project completion time is equal to, so 1 to 4 the duration is 4 plus 5 plus 5 plus 3, which is equal to 17. So it is given in weeks, so that is 17 weeks. So the project completion time is 17 weeks. So I hope this much is clear to all of you. Okay, now let's come to the last part of the problem, that is probability of completing the project on or before 22 weeks. That is the last part of the problem. So now we know the critical path and critical activity. So first what you need to do is, you need to write all the critical activities. So what are our critical activities? Critical activity is C, F, H and J. So what is the mean duration for each and every activity? For C the mean duration is 4, for F it is 5, for H it is 5, and for J it is 3. And then again the variance. So we have already found out this. We have already found the variance and mean duration before. So variance for critical activity. Now our critical activity is C. C the variance is 1. So you can write 1. Then for F again it is 1.78. 1.78. Then the next critical activity is H. H variance is 1. And then again the last one is J. J again it is 1. So the mean duration and variance of each and every critical activity is given. Now what you need to do is, you need to find the sum of this. So 4 plus 5 plus 5 plus 3 you will get 17. Then 1 plus 1.78 plus 1 plus 1 you will get 4.78. Okay, these two things you know. Now what you have to find out? You have to find out the probability of completing the project on or before 22 weeks. So you have probability of X less than or equal to 22 weeks on or before. So less than or equal to 22 weeks. So you need to write down the formula P of X minus mu less than divided by sigma. This is the probability formula, yes or no? X minus mu divided by sigma. Now what is X? X is 22. So you can write it is less than or equal to 22 minus. What is mu? Mu is mean duration, sum of mean duration, that is 17, divided by sigma. Now you don't know what is sigma. How you will find sigma? This is sigma squared, right? So since this is sigma squared, you have to find what is sigma. Sigma is equal to root over of 4.78. So you will get it as 2.19 weeks. This is 2.19 weeks. So sigma, you know, sigma is 2.19. Okay, so you will get it as P. Here, what is X minus mu divided by sigma? This is the formula for Z. In normal distribution, we have studied this formula. Say Z is equal to, so here this is Z is equal to X minus mu divided by sigma. This is Z formula. So you can write P of Z less than or equal to, what is the value of this? The value is 2.28. Okay, so this is 2.28. Okay, so here we have to find out P of Z less than or equal to 2.28. In normal distribution we have studied this. So for this we have to use the standard normal distribution table. So using standard normal distribution table, or you can call it as Z table. Okay, so here you can call this as the Z table. You should look for 2.2 under 0.08. So 2.28 can be represented as 2.2 under 0.08. Okay, that is how we look at the table. Now I don't have the table right now, so you can verify it using your Z table. So the value of 2.2 under 0.08 will be 0.9887. Okay, so here you get the value as 0.9887 using the normal distribution table. So this value is obtained from standard normal distribution table, that you have to remember. So here you can write, therefore probability of completing the project on or before 22 weeks is 0.9887, that is 98.87%. Okay, so this is the final answer. Okay, so here in this problem or project network diagram, you drew the project network diagram. After drawing the project network diagram, we computed the expected time and variance using this particular formula. That is, we have this formula, expected time T is equal to T0 plus 4Tm plus Tp divided by 6. Variance is equal to sigma squared is equal to Tp minus To divided by 6 the whole squared. Okay, using this formula you have to find out the expected mean duration and variance for each and every activity. After finding that, we have to find the critical path and project completion time. For that you have to use the mean duration, then find the early start time and latest completion time, and using that we found out the critical path, then we found the critical activity, and again the project completion time. Then the last part of the problem is whether to find whether this particular project will get completed within 22 weeks. For that you have to use normal distribution table. You know the critical activities, the different critical activities has been found out. The mean duration we know, variance we know, so find the total sum of the mean duration and sum of the variance. From that you have to find the standard deviation, and using the formula Z is equal to x minus mu divided by sigma, you can find the probability, and using the standard distribution table we find the value, and that value is the probability for completing the project within the given time. Okay, I hope this is clear to you. This is all about the PERT problem. Okay, thank you students.